Determine for the function g of x equals 3x minus 4 for x is less than 3, 3 for x equals 3, and 4 minus 3 over x for x is greater than 3, at the x-coordinate x equals 3, whether it is parts a through e. Each of the parts here involves the continuity of the function, so the first thing to do is write down the definition of what it means to be continuous. And that is, the limit as x approaches a from both sides of g of x equals g of a. Specific to this problem, we're looking at the x-coordinate of 3, so we can write this down for the x-coordinate of 3. Limit as x approaches 3 from both sides of g of x equals g of 3. We don't know whether this is true yet or not, so we'll put a question mark above it. The first thing to do is determine the limit as x approaches 3 from both sides of g of x. Now, g of x is a split expression function, and it's splitting right at the x-coordinate of 3. Therefore, the two-sided limit will have to be worked out by first finding the two one-sided limits. So we write down the left-sided limit as x approaches 3, indicated by the negative superscript on the 3. And the right-sided limit, x approaches 3 from the right side, indicated by the positive superscript on the 3. Let's start with the left-sided limit. The left side of 3 on a number line means less than 3, so up here at the split expression function, we will use 3x minus 4 for g of x. We can now replace g of x with 3x minus 4. The next thing to do is try plugging a 3 in for each of the x's. That will give us 3 times 3 minus 4. 3 times 3 is a 9 minus 4. And 9 minus 4 is a 5. We can now work out the right-sided limit as we approach 3 from the right side. The right side of 3 means to the right of 3 on a number line or greater than 3. And up here at the split expression function, that means we will use 4 minus 3 over x for our g of x. We can now try replacing each of the x's with a 3. That will give us 4 minus 3 over 3. 3 over 3 is a 1, and 4 minus 1 comes out to 3. To determine the two-sided limit, we have to compare the two one-sided limits with each other. Here they are. They do not match, and therefore the two-sided limit does not exist. When the one-sided limits do not match with each other, that's immediately a jump discontinuity. Which type of jump discontinuity we have is dependent on what g of 3 comes out to. The next thing to determine is g of 3. G of 3, x is equal to 3. We're going to look at the split expression function when x is able to equal to 3, and that's here. And according to that, g of x will be a 3, and therefore g of 3 will be a 3. To recap what we have here, we have the limit as x approaches 3 from the left side of g of x does not equal the limit as x approaches 3 from the right side of g of x. But then g of 3 does equal one of them. G of 3 matches the right-sided limit, so this up here does equal g of 3. So since the limits do not match from each side, it's a jump discontinuity, but because g of 3 matches the right-sided limit, that's going to be jump discontinuous, but it is called continuous from the right side. So we will have situation D, jump discontinuous but continuous from the right side.